to move on to Chapter 2, still within the function concept, and look at the types of functions. Chapter 2, 3, and 4 take us through different types of functions. And the first group of functions in Chapter 2 are these things called algebraic functions. Now, I'm not going to write everything out here. It's in the textbook. If you look at what we have in the textbook, there's a definition there as well. And you can kind of see it. Hopefully you can kind of see it reasonably there. It's written on a lot of different words over here. So rather than writing all those words, what I will do is just kind of state it simply. Here's a kind of a simplified or abbreviated definition of an algebraic function. I'm not going to put all the details here, but they are in the textbook. An algebraic function is a function using the basic properties of arithmetic any addition, subtraction, multiplication, division, as well as raising to a power, raising to a power, as well as taking roots. Doing those things to variables and numbers a finite number of times. That's critical. That's what makes it algebraic. It's a finite, not an infinite, but a finite number of times. So we're going to look at a whole class of functions we call algebraic. And I'm going to list them over here just so you see what they are. The ones that fall into this category are things called polynomials, or polynomial functions. Okay. The other types of algebraic functions are going to be all the radicals or the roots. Radicals or roots. Or if you're over in Europe, they call them surds. In addition, I should put over here the absolute value operation. We might have some absolute value functions. As well as the last group of these algebraic ones are rational functions. So in Chapter 2, we're going to kind of go through and look at all these different types of functions that are called algebraic functions. And some of the important things that we want to know about them, obviously, since they're functions, we want to know their domain and ranges. So that's where you're going to see this again. Domain, pretty much the natural domain here. Later on, we'll talk about restricted domains and stuff like that. But for now, it's just going to be a natural or domain. We'll call it domain. So let's start with, essentially, we have in 2.2. 2.1 is just this idea of what are algebraic functions. There's no homework from 2.1. It just introduces the entire classification of these types of functions, which I get by just taking my variables and numbers and just, polynomials, multiplying by something, raising to a power, radicals, we're taking absolute values. Okay, 2 are just radicals or roots. These are the radicals or roots. 4 are the rational functions. We'll see this. Just put over here. There's a polynomial function. Just to give you an example, is 2x squared plus 3x minus 5. That's an example of a polynomial. This is an example of a radical function. So it's, the square root of x minus 2. That's a radical function. Here's an example of a absolute value function. Absolute value of x minus 5. And here's an example, if you will, of a radical function. So it's x plus 7 or x minus 4. So the name comes from, that's a polynomial expression. And when I set it equal to, say, a y value, it becomes a function. That's my radical, a square root expression. It becomes a function when I call it a y value. That's my absolute value expression, and that's my rational expression. It's a ratio of these polynomials. Okay, so we're going to start now and move to 2.1. Well, also in 2.1, there's also some, I should point out, this is the beginning. 2.1, we just talked about the power function. So let me just correct over here, going back in my head. So this is the type of functions we're going to be looking at over the next couple of classes here, getting comfortable with these. The first test is going to have a lot on it. It has a lot of all the different functions we're going to be using throughout the course. So I don't introduce them piecemeal. I show all the functions, and then we delve into them and start to analyze them more directly. Okay, so let's take a look at how we begin to form some of these other subclass of functions. And the first type of function that's really a subset of a polynomial function is a power function. So that's 2.1. There's no homework on it. It just introduces the concept of a power function. This is 2.1. So this is the most fundamental type of function that we have. And all it is we take our variable x and raise it to a positive exponent power, x to the n, where n is equal to 1, 2, 3, etc. Only positive numbers now. That's called a power function. And let's take a look at some of the pictures. So here's some examples. We'll start very simply. Here's the first example. N is equal to 1. X to the first power. What does the graph of that function look like? That's just the graph of y is equal to x. Remember, f of x is just another way of saying y. So here's the graph of that function. That's my graph of that first power function we have when n is equal to 1. Now you might notice some information about the domain and range. The domain is I can put any value in for x, and I can get a value y out, or f of x out. So the domain of this is that x is any real number, from minus infinity to plus infinity. What about the range? Well, the range in a similar fashion is that y can also be minus infinity to plus infinity, so y is also just any real number. Okay, so there's our first power function. Let's move on. Let's look at n is equal to 2. So now we have our next power function, f of x is equal to x squared. What does the graph of that look like? If you can't do it in your head, you have your resources at your disposal. We talked about Desmos and your calculator. You can use that. This looks something like this. Again, what does the domain of that function mean? What can I put in? Well, notice put in an x value I want. So x in this case, just like it is for the x to the first power, can be any real number. Let's see, x is an element of real numbers. The range is a little bit different. Notice I'm never going to get, my blue line never goes beneath the x-axis. So in this case, we say y has to be greater than or equal to 0. It's also a real number, but it always has to be strictly positive. It can't be negative. Okay. Let's see more behavior of these power functions. Let's take a look at the third case. You start to see a pattern forming. So f of x is equal to x cubed. What does its graph look like? So if I come over here, plug everything in, plug it into a calculator, I'm going to do my head calculator, it looks something like this. That's my cubic function. What is the domain of that? Again, I can put any value in for x. Doesn't matter. Put a number in for x cubic, no matter what it is. So my domain x is, again, any real number. What about my range? Well, notice y can be any real number because I'm from minus infinity to plus infinity. It's the y value in the vertical direction. So y is an element of the real numbers. Let's do a couple more, and you might see a pattern that develops. So let's take my f of x equal to x to the 4th power. Plug it in over here into our little device, whatever it is, a computer or a calculator. It'll look something like this. Very similar to this, it's just more pulled in and stretches out higher up. Again, like all of these, the domain is any real number for x. The range, however, is restricted. It's very similar to this. So y has to be greater than or equal to 0. This doesn't dip beneath the x-axis. Let's do one more, and hopefully you kind of see the pattern over here. Here's the 5th one, and f of x is x to the 5th. What does a graph of that look like? And looks something like this. What's the domain of this? Again, you kind of see, I can put any value in for x. So the domain of any power function I care to write down is any real number. I never have to worry about the real number. The range, however, is dependent upon whether or not the exponent is an even or an odd number. When it's odd over here, the range is all real numbers. Same thing over here. The range over here is that y is any real number. If it's even, the range always has to be strictly positive, strictly non-negative, I should say. Can't be negative. Can be 0 or greater than 0. So that's our power function. That's one of the fundamental type of functions that we have. We use that to make up a lot of functions.